Okay, so let's do it. With increasing technology, there is a very high chance that misconceptions may enter our minds. It's very obvious. Today I'm going to talk about 5 such misconceptions about CPUs. Roll in the intro. First point. This is something which many of us think. Core count and clock speed cannot really be used to measure how powerful a CPU is. If you have been in the line of technology for a while, you must have heard someone say that a CPU has 4 cores and it is clocked at 4 GHz, and another CPU, say CPU B, has 6 cores and is clocked at 3 GHz, and since 4 cores are 16 is lesser than 6 3s are 18, therefore CPU B is better than CPU A. Well, this is not at all the case. Yes, core count and the clock speed matters, but it really does not matter how powerful a CPU is. But when we come to the case of real life chips, there are many more factors that we should always count to make to consider whether a CPU is more powerful than another one. There is, for example, the cache limit. So it's totally wrong to consider a CPU that has more cores and just more cores but lesser frequency, or to be more powerful than CPU that has less cores and more frequency. Let's move on to point number 2. Clock speed it matters, but is really not the important indicator of performance. When a CPU is built by companies like Intel and AMD, the main thing that is kept into mind is the architecture of the CPU. And there is another thing called the L1 cache, the L2 cache and the L3 cache, which determines how powerful the CPU is when it comes down to calculating and performing tasks that is being given to it. So we cannot really consider the core speed, the clock speed or the clock speed as the main indicator of performance. Let us move to point number 3. Well, this thing used to be true at the time, but with time, this thing is really getting out of date. This thing is really becoming less and less true. Nowadays, the point that dominates the market is heterogeneous computing, and it is SoC, system on a chip, that really runs most of the devices. Well, desktops and laptops have quite a lot of space in which you could include different chips for performing different functions, but the increased availability and increased use of handheld devices like mobile phones and their handheld consoles, a separate chip for each function, like a separate central processing unit, a separate graphical processing unit, a separate storage device, is really not that much effective and power efficient. So system on a chip, or SoC, is getting more and more popular by the day. Most of the mobile phones run on an SoC, and in an SoC there may be the CPU, the GPU, the RAM, the storage, the media encoder, the media decoder, and dozens of other things that is built into the SoC. So a CPU is just a part of the chip that runs most of devices today. Well, the chip, we may also consider the motherboard that is built into the desktop and laptops as the SoC, because it is the main chip which handles the different processes, and we have the CPU, the GPU, the RAM, the storage devices, otherwise some of what connected to the motherboard. So the SoC thing was there, it's nothing truly completely new, but the way that SoCs are built is getting better, is getting more advanced, has changed. But SoC is a concept, and you'll have to understand that SoC runs the device as a whole. The CPU is just a part of the whole system, the whole SoC. Let's move on to point number 4. This is the thing that you must get out of your brains, that the feature size that the chips come with are a real indicator of what performance you would get. We see big companies like Intel and AMD are boasting smaller and smaller chips, smaller like 7. There are first get it off clear that there are 5 different types of sizes that are popular nowadays. First is the 22 nanometer, which is not really that much popular. And then you got the 20 nanometer, which is mostly manufactured by Samsung, and it runs quite a few, but it's more popular than the 20 nanometer nowadays. Then you got the 14 nanometer, sorry. 14 nanometer is quite popular. And then we got the 10 nanometer, which is found in some high-end devices, like you may buy GTX 1080 Ti, and then you got the RTX 2080 Ti. These high-end graphics cards have the 10 nanometer process. Some CPUs maybe from the 8th to 9th generation of Intel have the 10 nanometer process, and AMD for some generations like the Ryzen 1st and 2nd generations have the 10 nanometer process. So 10 nanometer is common, and now at this point the size of chips that are becoming more and more popular is the 7 nanometer, with AMD 4th generation is bringing the 7 nanometer. The Tiger Lake processors from Intel have the 7 nanometer process, and futuristic, which will come in the future, the 3 nanometer process. So these things, AMD is boasting a 7 nanometer process, like this say that 7 nanometer, Intel has not bought 7 nanometer, so our product is better. Well, it's not like that. You will never get a performance increase because of a smaller process size, smaller transistor size of chips. It is just a myth, and myth busted. Let's move on to the next point. Point number 5. Now the last point, and that is processors will keep getting faster. No, it will never. Processors will not get faster. There's a limit to which they can get faster and faster and faster. No. Okay, let me just tell this one by one. First, what are the things that are really required to make a processor faster? That is, first of all, a bigger chip can give bigger performance. Second, more transistors can give bigger performance. And third, smaller transistors. Yes, smaller transistor can give better performance in a way that, suppose you have a small chip, maybe a 5mm by 5mm, well, that is a really small chip for handheld devices, and another chip 6mm by 6mm. So if we get smaller transistors in a 5mm by 5mm chip, well, let us suppose like the 1 million transistors, 1 million processors are supported by a chip. A 6mm by 6mm chip will obviously support more number of transistors, so no more number of processors. But if we make this size of the transistor smaller, like from 7 nanometer to 3 nanometer, the number of transistors will surely increase. Well, these are the 3 ways in which you can make a chip, a CPU perform faster. But first, let me say, the first point which I told is that a bigger chip can give faster speeds. But we have really reached the limit of which we can get a bigger chip. A bigger chip will require more power and more better cooling devices, and we have really reached the limit to which we can provide power to a CPU and which we can cool a CPU. So getting bigger devices is not the way out. The second process, getting more transistors. The 3 nanometer and the 7 nanometer processes have reached the limit of which they can accommodate, a chip can accommodate more and more transistors in it. In many cases, 2 transistors are separated by an atom or 2. An atom is a fundamental unit of matter. You cannot divide an atom more. So when it comes down to 1 atom, there will be no more space to add another transistor to increase the space by limiting the space between the 2 transistors. And smaller differences in gap between 2 transistors mean smaller wires, and smaller wires mean more resistance. More resistance means more power drawn. So getting more transistors that fit into a chip is not the way out. Now the third process, getting smaller transistors. We have already got 7 nanometer and 3 nanometer chips, 3 transistors inside a chip. And in this very, very, very small size, quantum physics comes to role, and some laws of physics comes to alter the functioning and the processes that are carried out by the transistors, often damaging them. So it's not the way out. So we have reached the limit of the getting a faster CPU. For the past 40 years, for the past 4 decades, we have always been seeing a jump in the number of transistors within every couple of years, but that may not be the case for the upcoming years. And for the past 10 years, the CPU speed has been constant at 3 to 5 gigahertz. It has not increased ever since. So we are actually reaching the end of getting a faster and faster processor. Processors will not get faster over time, get it clear. Okay, so that was for today's video. I hope you liked it. I hope you got some misconceptions out of your brain if there were. And let me know down in the comments of another misconception that you may think, that another concept that you may think is a misconception. And with that said, I'm Cyber Tech Talk, and I'll see you in the next video. Bye.